Hey everyone, how are we doing? Good morning. Happy Monday to everyone. Good to see Kayla here. Roderick, what questions do we have? I'm working on assignment 10. Let's see right here. Cora's here. Just trying to have a productive morning. Good morning, everybody. Bailey's here. Does anyone in stat know how to do the open-ended on the content quiz? We could take a look at that right here. I saw Andrew in here. Jessica, good to see you. Who all is here and what questions have? Oh, I'm still really confused how to do the write-up interpretation part 2. I do not understand how to do the when writing the equation. Let's take a look at that. Let me download the assignment. We'll do a little 320 right here. Let me get everything. I was replying to some emails and getting ready to do. Let's take a look. Ask all the questions that you have right now. We will start looking at them. Mubot is awake. We'll give out some points here in a moment. I see some Canvas content in chapter 16. Yep. Let's take a look at that. We'll take a look at BAS 320, and then we will take a look at 201. Let's do this. I think the question is about the chlorids line. Okay, there we go right there. We got it up. Let's take a look. And do you know when project 2 will be graded? I told them by Friday. So if you got it in early and if I reviewed it, you should be pretty good. So I told them by Friday. I sent an email out this morning. I was like, make sure it's graded by Friday because Friday was the turn in and we like to have a 1 week turnaround. So I'm hoping that the graders, they're busy too, but let's hope by Friday that they have it graded. And it looks like chapter 16 homework and content quiz. Yeah, let's talk about that next after this. You got it. I turned it in on Tuesday. Yeah, last week. So and then they have until Friday of how did the percentiles interpret? Yeah, I'll do it. We'll do a little 320 right here. Let's do that. Let's hop over to 320. Let's do it. Okay, so with 320 right here, let's go down and I left in some of the code right here. For the first thing Cora was asking about is task 1 part 2. Task 1 part 2. Okay, good. Am I doing the right one? I'm doing the right one, right? Here we go. Okay. So we've got here the line. I left in this stuff right here, so it still exists. And I left in the VIFs. So explain the coefficient of the interaction and how it impacts the sulfates. Let's go ahead and take a look at this. Let's look at the visualize. I wouldn't put this stuff right here because this is not going to produce output. But let's just take a look at it, make sure your output exists, make sure you can show your output, make sure that all exists. Just looking at this visually right here, I know, Caitlin, I want to see the grades too. I'm like, I sent out a big thing to them this morning talking about it. Let's get out some points too. So what's the first thing you notice right here, Cora, about the way the interaction impacts the line? So when you look at this right here, sulfites has a what relationship with alcohol? Just look at this line and this line. Just think about talking about it for a moment. Sulfites has a what relationship with alcohol in this model? So we've got this issue right here, and we've got this issue right here. So think about how it would be interpreted while we take a look at the summary of it. So we've got the output over here next to it, and then we've got the line. I'm going to do something to help out real quick. Where's my visualize? I would not suggest doing this. Don't do this. Oh, does it not like that? Oh, good, it did it. Don't do that, though. Don't do that for your output. Okay. It just makes it so we can actually see this line over here. So when you look at this model right now, look at the relationship sulfites has with alcohol. Everyone's like, yes. I love it. Everyone's like, yeah. I love all the congratulations. Thank you so much, Caitlin, everybody. All the positivity. It's so much fun to everyone's like, we got the all-stars here today. I love it. Like people are just, you're almost there. You're getting close to that, Caitlin. Great job, Caitlin and Kayla. I love the positivity. So when you look at this right here, take a look at this line right here and look at its relationship. Take a look at the line right here and look at its relationship. I find the points are so much fun. So how are we describing this and what does this output mean right here? Great job, Ella. Like I said, we got the all-stars here today. Ella, you're almost at the next, you're 500. You know what? Whatever. We got the all-stars here today. Let's just go crazy. Let's get Ella to that next tier. There we go. Don't tell. Slightly negative. Okay, so this one is slightly, exactly. So you're on the right track, Cora. when sulfides are, this is the lots line. I have to bring back the output for us to see it. When sulfides is little, when sulfites is little, this is what we have right here. The coefficient is going to be slightly negative and basically zero. Like when sulfites, oh my gosh, when chlorides are little, the relationship with sulfites is slightly negative. The relationship alcohol has with sulfites when chlorides are little is slightly negative, and it would be this coefficient right here. Does that make sense? When chlorides are little, the relationship sulfites has with alcohol is slightly negative, and it is this number right here. Sometimes people use them interchangeably. I don't. I wouldn't say they're exact same. When we see that chlorides is lots, the relationship will increase by this much because this is the interaction term right here. Does that make sense that this is the interaction term? So this is the change to the slope. This is the change to the intercept. The intercept is this much lower, which we're not really seeing the intercept right here because that's 0.2. But if we were at 0, it would be the intercept difference between these two lines. This line is at 10.8 back here, and this line right here is negative 1.7 lower on the intercept because this right here, the indicator changes the intercept, but the interaction changes the slope. So the slope of this line right here is 1.02 more than this line right here, which is negative. So what about is the slope of this red line, Cora? Just do a quick guesstimate in your mind. The slope of this line is about what? Which will tell you the answer for the next one. Good to see you, Morgan. So this will tell you the answer for the next one for writing the line. Just be careful because make sure when you look at this line, you should be like, oh, the slope for this line is about what? For chlorides lots. What is about? Just do a quick guesstimate in your head. Kind of what is the slope of this line for chlorides lots? Because you'll put a 1 in here for chlorides lots. Chlorides lots will become like a 1, and then you'll add the like terms. So the slope of the chlorides lots line is what? What would be the slope of the chlorides lots line? You can do it just a guesstimate. Kind of. Do you see how this is the negative slope right here? That's the slope of this black line right here. The slope of the black line is this right here. That's the slope of the black line. So now let's add the interaction term to it, and we can get the slope of the red line because this is the difference. Like what you'll do is you'll put in a 1 right here, and then you have sulfites times this plus sulfites times this, and this gives you the slope of the red line right here. Does that make sense, Cora, right there? This is the slope. It's basically 1. You are correct. It's about 1, but there's a lot of things in here that are about 1. It's because we're adding the original slope and the interaction together. And what would be the intercept of this red line right here? So we're actually solving the next part of this. What would be the intercept of this red line? So you have to take the original. Yep, Corey, you see it. Awesome. So what is the intercept of this line right here? The intercept of the chlorides lots line. Remember, you'll plug in a 1 for this. So you'll solve through the equation by plugging in 1 wherever you see chlorides lots. This changed the slope. This will change the intercept. So just do a guesstimate. You can just guesstimate it, and then I'll show you. And this is literally the answers to the question, as long as you write the equation of the line. So, and then you just write in the equation of line like y equals mx plus b, but y equals b0 plus b1x, or y hat. So this will be the difference in the intercept. So this value right here represents the difference in the intercepts. So the intercept, if you look where it hits, it's not going to hit at negative 1.77. It would be somewhere, yeah, Roger, yep, Roderick's on the right track. How did Roderick get that? Great job, Roderick. Yep, this is good review, right? And so look right here. If we take the original intercept, which is 10.8, which hits back here, then we would subtract off this right here. And there's the, does that make sense how we're getting that value? Yeah, let's do that next here, Maya. You got it. We're going to do some Canvas. So we will do some Canvas content next. My hair's just going all crazy. It's funny watching these videos and just watching my hair get crazy long. Yeah, and so that's the, does that make sense, Cora, that this changes the intercept? These are the slope ones. Like these only work on intercept. Like this and this are only intercept related. Like this is the original intercept. This is the intercept for chlorides lots. This is the sulfites slope, which is very small and negative. This is the difference in slopes because the interaction changes the slope, but indicator variables only change the intercept, which is a big concept we've been covering, how the interaction right here would say that the way in which sulfites impacts alcohol depends on the chlorides in a wine. So the way in which sulfites impacts alcohol depends on chlorides. When sulfites are very little, there's a negative relationship that is very weak. When sulfites are lots, there's a much stronger positive relationship right here, which we can see with the coefficient of 0.989. All of these numbers right here are great to quote, and we actually have just found the intercept and the slope of the new line, this red line. That's the intercept of the red line, 9.08. It would hit somewhere back here, and the slope of it is about this. So, Cord, does that, we'll do one more question on 320, then we'll hop over to 201 after this. How does that work on writing the equation, interpreting the interactions? Does that make sense? Like if someone's watched this, hopefully they can be like, okay, I know what to write down. Like I didn't quite write down the answer, but I want to kind of leave it there if you're following along and you kind of take what I've said and put it together into one cohesive kind of sentence. That way I haven't come awesome. That's why I like to see Cora. Cora, thank you so much. And everyone, thank you so much for all the positivity and everything. That's what I really like. I like all the interaction. You guys, everyone knows. Let me just say this. It really means a lot to me that when everyone talks to me, like gosh, it really means a lot. Like I have people who tell me like, I go to my class and nobody talks. And I'm like, you have to ask them to talk. You have to talk to them. Yeah, Positivity Monday. Kaylin knows what's up. Let's round another 100 points. Just crazy Positivity Mondays. You got to talk to your students. And I'm not saying that they're not doing that. You have to start with that. And so that's my suggestion always because I'm going to be helping out. Here, we'll go to the main screen for a second here. I'm going to be helping out with a class. Oh, thank you so much, Andrew. So thank you, Bailey. I'm going to be talking to some new teachers. I do a thing every summer. This is my third summer doing it, where I speak to new PhD students who are about to graduate, and I think they're about to go out in the world and start teaching. Like they've been hired by their universities and stuff. And so I always give them advice on how to like teach, like how to do what I do, and how to do what they're going to do. So hopefully, they're just going to say like me all the time. I had a teacher who would take off 1 point every time you said in like you'd have to do reports. If you said or or e or just whatever, if you had a filler word, she would take off a point and she'd say, you said 5 times. I took off 5 points. I'd be like, no. I think there was one more question. I say all the time. I'll be watching my videos, like doing timestamps. I'll hear myself saying, was there another 321? I can't stand out of the classes are so quiet. Yeah, no, right? It was going to be the one to start talking, but I have a teacher. Oh, thank you so much. Yeah, don't worry. If you're talking to other classes, don't worry. I always tell my students, I'll tell them this in person. I'm like, can you remember something like not stupid, but like something embarrassing that someone else said in a class? Sometimes someone will remember something like, oh, in this one class, this one guy raised his hand and was like, said this thing. And I'm like, it's super rare, but we usually remember the things we said that embarrassed us. We rarely remember like things that other people say. Like if I said like, remember something someone put in the chat that was embarrassing. Can you remember through all of stats 1 with everything everyone's texted throughout this class? Can you remember like, oh, I remember that one time someone put that in the chat and I was like, oh, it's so embarrassing that they wrote that. Like I promise you, most people are more like we start to realize this, that most people are more like focused on like, oh no, I wrote this. Like they're more concerned about like what they write instead of like critiquing what others write. Not even once, exactly. And then we might write something in the chat and be like, oh, I wrote that one time. I wrote blah blah blah, and oh, Andrew Wind is the best. Was there another 321? We'll do. I think people want to talk about Canvas content real quick. I swear there was another 320, and we'll do that real quick. I've got this long break in the video right now. We could come back and do 320. Was there not another 320? Maybe not. Maybe not. That's is that embarrassing right there, Andrew? Andrew is the best. Let me pull up 201 Canvas content while we're talking. Okay. Andrew, that is so Aaron, I am embarrassed for Andrew. I am just Andrew. God, I'm so embarrassed. You know, like Napoleon Dynamite, I have a greater appreciation for it, but I've never loved Napoleon Dynamite. I don't know why. I feel like it's a movie I should love. I probably just need to see it like 10 more times to eventually. I mean, like I think it's an okay movie now. I'm starting to appreciate it more. I've just really tried. But you don't have to love every movie. I'm just bummed because I don't know. I just feel like it's a movie I should like. Which question were people wondering about on the Canvas content? There's an open response question. A new diet. Okay, I think it's the new diet, right? Let's go grab the new diet question. New diet question taken. Okay. I guess the new diet question. Okay, let's head back over here. Let's see what we're talking about. New diet. Yep. I'm in SCM, all that good stuff. The new diet one. Let's talk about the new diet one. Have you watched The Expanse? I have not. Let's go talk about the new diet question. Here we go. Okay. So for this question, hey, Emma, good to see everybody here. And please keep asking questions. We'll line them up. The more questions people ask, the more we have lined up, the more we do. So with this question right here, what's the first thing Brian's going to do? Just think like Brian for a moment. Be like Brian. BLB. Be like Brian. What's Brian going to do? What's Brian always say when we see a question like this? Like immediately I'm like, you know what we should do? What should we do immediately here? I'm going to get it ready. What should we do? What would Brian say? What would Brian say if he saw a question like this immediately? Notation. Caitlin, great job. Let's throw out 50 more points. Caitlin, you're exactly right. Write out what we know. Know the notation. Exactly. We're going to be like notation. That's where we make sure we know our notation. They got this average of 6 weeks. I don't think that matter. 25 people are chosen randomly. I see sample. Those are keywords right there. I'm kind of little here. Let's do this. Okay. So what do we see here? Okay. Kind of got everything highlighted. Good way to go. So what is the notation in here? Does anyone know any notation? What notation do we have? I'm gonna mostly solve this. I'm not gonna solve it out completely, but I'm gonna mostly solve it. And I should. It won't be p hat. So p hat. Good job right there, Maya. Good work right there. P hat is going to be sample proportion. We do have an n though. We do have n is 25 sample size. So that is correct. And I think a lot of times people default to p hat. I don't care. We're just going crazy. It's the end of the semester. It's crazy point times. Maya and Bailey, thank you so much for those answers right there. Do not worry. We're here to practice. You're basically right, Ella. You're basically right. 10 is what they're claiming. And this is where we have to practice because with 10 is the claim. So you're on the right track. This is almost mu. It's close. And this is going to be y hat. Or y bar. Sorry, actually, I made it. It's y bar. It's y bar. Y hat is the predicted, and we get that in regression. Y bar is the mean. Y bar is the sample average, the sample mean. Bailey, you're on the right track. Yep. This is the claimed mean. That's the claimed mean. That's mu naught. So that's the mu naught. Don't see, we're all working together. We're figuring it out. This is the way it goes. Sometimes we just gotta, I promise you, if you were to talk to people in the class, they'd say, you guys are the all-stars. They'd be like, you're the all-stars. And they need to see that we all practice. We see, oh, wait a minute, not y hat, y bar. Okay, mu naught, because it's the claimed or the hypothesized. The reason it's mu naught is because it's the claimed mean. They're saying this is the claim right here, so that's mu naught. And this is the sample average right here, y bar. So it's all practice. I promise you, people in class, I'll ask them, they'll be like, oh, those people know it so well. And I'll be like, cuz you got to practice. You got to practice. Got to get your head in the game. We got one piece of notation and we're done. One piece of notation and we're done. One piece of notation and you're done. One piece of notation and you're done. Everybody having a great time. Exactly. Practice makes progress. It's the only way to do it. Exactly. Yeah. I don't care, Bailey. Great job right there, Bailey. Bailey's got some. That is top tier notation, Bailey. That is the standard deviation of the mean, which that is like. Don't worry. I don't usually do this. You can call it SD. Some people call it SD. It's technically lowercase s. SD is a fine because it's sample standard. It would not be sigma because that's true standard deviation, or hypothesized sigma because that's not a hypothesized true standard deviation. So it can be S or SD, and sometimes people put the sub y bar right there, like the standard deviation of the y variable. I think it should just be standard. I think that's right. Yeah, that's right. I don't usually put, but so technically you could say standard deviation of the y variable, especially when you have more variables like an x variable and a y variable. If you're doing like correlation and stuff like that, which uses those in the formula, you would do standard deviation. And it is related to the mean, but we usually say standard deviation of the y variable, like the variation in the y variable. I usually just call it S right there. And now we're almost done. No, this is all the work right here. This is everything like great work, great practice. Uh, I don't mind. I'm just going crazy this morning. You tell everyone Brian went crazy during off stars. He gave away just like tons of points. I've given away like 700 points right now. A T with n-1 degrees of freedom. No. Say, Brian, don't put a star. This is not a confidence interval. You do not get to pick that T. You do not get to pick that T, Brian. You know, let's change the color anyways. You do not get to pick that T. That is not a T we pick. That is a T that is chosen via the percent oh my gosh. As I'm selecting a color here. That is a T that is solved for. This is the standardized difference. This is the standardized difference between what we see in a sample and what we hypothesize is true. So this T right here, which we're going to differentiate from a confidence interval, is the standardized difference, and that's the degrees of freedom for it. Oh, thank you so much, Caitlin. We're just here for some positivity and to practice. I guess the only other thing we left off, let's just do one last thing here. What is the only other thing in notation we haven't mentioned? Not that big of a deal, but we should just know it since this is a T. All T's have this, and it is this for this. Bingo, Bailey, just boom. Just like, awesome job, Bailey. We're giving out points for everything today. Tell people show up. Hashtag show up. The degrees of freedom equals 24 because n-1. Hashtag show up. Yeah, that's got it. Oh, thank you, Morgan. Maybe you're talking about me. Hopefully, I don't know. I like solving problems. I like having fun. But this should get it solved. This was good practice right here. Knowing your notation, being able to identify and work through the steps in the problems, the key. Work through the problem. So it's a T with 24 degrees of freedom. Well, I think you're on the right track right there, Bailey. So it's not that T equals 24. It's that the T is a T distribution. Oh, thank you so much. You guys are so awesome. It's like Kayla, shout outs to Kayla right now. Practice makes progress. I think because that's better than practice makes perfect. Because I'm not, you see me say yes in the chat if you've seen Brian make a mistake on my Pearson question. If you've seen Brian make a mistake on my Pearson question, say yes in the chat. Because I've seen myself make mistakes on those. So the final answer will be found via the formula right here. Does that make sense? I don't want to solve everything out. So to answer Ella's question, Andrew's never seen it. Andrew, you need to watch more streams. We are solving for this T. Oh no, the p-value won't always be 0.05. Like, let's say we were to solve this out. Here, I'm gonna do a virtually identical question. Oh, thank you so much, Morgan. Let's do a virtually identical question. You ready? This is a virtually identical question. Brian claims that his students are the best students ever. He claims they make above a 70 on the final, which is amazing. Let's say 75. The average on the final is usually mid 70s, and I'm going to say my students make above a 75. So you should identify some notation right there, and this is like a grade, so it's quantitative. From a sample of 100 students, we find a mean of, let's say, 77 with a standard deviation of, I'm thinking I'm cheating. I'm using numbers I'll be able to solve. 5. Sure. Find the test statistic and p-value. Okay. So the only thing it's wanting you to solve right here for is the test statistic. So this is you guys are so awesome. I really appreciate it. I get some bad reviews every once in a while. So people don't like me at all. It's whatever. Thank you, Kaylin. You guys, and it's just practice. We're just hanging here. We're doing a 1 sample t-test. Let's make this very clear. This is a 1 sample t-test. So 1 sample t-test. Okay. 1 sample t-test practice right here. So 1 sample t-test practice. What do you see notation-wise here? What do you see notation-wise? And we're going to find the p-value for this. The whole goal of this is to find the test statistic. This is the exact same type of problem, exact same information as you were just doing. Everything identical for let's just solve test statistic. Oh, you guys are so, I don't care. 50 points. You don't have to. I really appreciate it. I want us to just have fun and do statistics. Great job, Caitlin. My goal is even if people are not good at mathematics, they can still make a B in this class. I'm not saying I have people make A's in this class tell me I'd never make an A. So I have people be like, I am horrible at math. I made an A in Brian's class, and that makes me really proud. But I really want everyone, no matter what your skill level is, to brag on Brian Mondays. That's what it seems like, right? Wait for my problems. This is the mean is Ella, are you on Discord? If you can send me a screenshot of it. Can you send me a screenshot? Are you on Discord, Ella? If you can just send me a screenshot really quick, I'll take a look. Here, I'm gonna highlight a few other things. We've almost got everything identified. So what else do we have right here? We've almost got everything identified. Or you can send me, if you send it to me, I'll take a look. That doesn't sound correct. What else do we have notation-wise here? Here's a hint for Brian claims. So Brian's making a claim. So that, wait, that'll be the claim? So since that's the claim, it'll be what? You can spell it out since the standard deviation of y is this. So that is the standard deviation right there. So the 75 is the claim. The 75 is the claim. So the 75 is the claim. This is the one, this is the new notation usually people get stuck on, which is all right, don't worry. This is the new notation that people usually get stuck on because 75 is the claimed mean. Great job, Bailey. Yep, it's mu naught. Does that make sense right there? It's mu naught. Awesome. 2 seconds. My hair is getting so long, everybody. I'm not used to this. It's just every day. There we go. And then 70, exactly, Bailey, exactly. Mu naught. Because that's the claimed mean. That's the hypothesized. The naught right there means hypothesized. So this is hypothesized mean. This is sample mean. Does that make sense? The bar represents mean of a variable. So we're just calling it the variable y. You could call it variable x, variable q, because we have letters that are usually reserved. But this y bar right here means mean of the y variable. And so now let's go ahead and plug everything in. And I made this nice and neat because you'll notice if we go here and we go y bar, and this is what you're solving for in your question. So I'm doing the same sort of mathematics to kind of answer Ella's question. I'm going to look at your email real quick here in a second, Ella. Does anyone see what this will solve to? What will this solve to? Can anyone solve this? Take a moment and solve it, because if you notice, I made square root 100, which makes my life nice and easy. So what will this solve to? We'll put it right here. 2 over, am I blocking that? I am blocking that a little bit. What will this solve to? So what does this solve to? When you solve this whole thing right here, which I did in a really weird order, this whole thing will solve, because this is its own sort of like 4. It solves to 4. Great job right there. It'll solve to 4 because this solves out to 0.5. So 2 divided by a half. So that solves out to 4 right there. And just practice through solving this. Make sure you can solve like equations like this. Just double check your work. Do it slowly. Remember, this will solve out, and it'll be 2 divided by this, which 5 over square root of 100 is 5 over 10. 5 over 10 is 1/2. 2 divided by 1/2 is 4. And so when we solve all this out right here, this right here is the test statistic. This is the t right here. So this solved out to the t statistic, which is the test. It's just happenstance that t and test have the same. The test statistic is the standardized difference. There's the difference. There's its standardized. Oh, that's all right. Don't worry, Morgan. That's just, we're here to practice. No one's going to remember. I won't remember. Like a week from now, I'll be like, Brian, remember that question I got wrong? I'll be like, I remember the ones I get wrong. Like, I remember my Pearson ones I get wrong. Like, I can tell you, like, I got which one wrong. It was one of the ones about, I think, the confidence interval, if it contained the value or didn't, and I said it didn't, it didn't. And I was like, whoops, I looked at that one wrong. So now this is literally the answer right here. Just to make that super clear, and then I'll look at Ellis here in a moment. That is the answer. This is step 2. This is step 2 of finding the test statistic. Yeah, here we'll do that here in a moment, Marley. You bet. We'll do that. I think people would be very happy if we did that next. Step 3 is to find the p-value, which means I need to go to a t-test or t-applet with degrees of freedom equal what? So what are the degrees of freedom equal to on this again? Here's what my picture is going to look like when I eventually go there. Here's the p-value. And I'm going to a t, and the degrees of freedom mean which t I'm going to. And this is equal to 4. The t, and so this one has 99, oh gosh, I wrote something wrong. I did not do that on purpose. 99 degrees of freedom, 99, yep. See, even I was thinking about the sample size and I forgot to do -1. It's the sample size -1 is the degrees of freedom for a 1 sample t. That's just repeat in your head. N-1 for 1 sample t, N-1. So Bailey, you're very close, Bailey. You've just done the reverse. So reverse it around. He claims that the mean is above. And so one thing we didn't do step 1 right here, but I'm probably trying to do the what alternative to 75. If you were to go back in time, and write out the null hypothesis, I have to get really close to write this. Does that make sense right there? The alternative is going to be that Brian says his students make above a 75. The null is that they make a 75. The alternative is that they make above a 75. Does that make sense right there to everybody? So which way is Brian shading on the graphic down here? So we landed at a t of 4. Do you see how we landed at a t of 4? This is where the t statistic is. And we are shading what to that? Since we're doing the greater than alternative, we are shading to the what of it. Since we are doing the greater than alternative, we are shading to the what of it. And we're going to do some chapter 16 next. Since we are doing the greater than alternative, we are shading to the what of it. Because the alternative always tells you which way you shade on the curve. To the right, exactly. So if you take Bailey's p-value, Bailey got the right p-value basically. So we go here. We go to a t with 99. Great job right there, Emma. We go right here to 99. We enter in a t-value of 4. And there's our t statistic, our t-value, and we shade to the right. And it's basically 0. So Bailey's p-value, which should be like 0.0001 or something close to that, it's so small that the t-applet's not even registering it. Can you go over the problem of the, yeah, let's do that one next. You got it. Yeah, let's do that one next. We will do that next. You got it. Who feels like this is making sense? Like, let's see, it starts to like disappear. It gets, oh, really? After this point, it's so small, it's not even recognizing it. I think we'll do it one next here, Mallory. You got it. Is this making sense that here's where we're at? This is where we landed. Here's the area to the right of it. And the area to the right of it is basically 0. And that's what I'm drawing out right here. Like I did a drawing of it and it's very, very small, which means step 4. Yeah. And then, yep, that's what we actually have next, Ella. Thank you for reminding me. Step 4. What are we going to do right here? What are we going to do right here? Reject the null. When it's two-tailed is when we have the does not equals alternative. If we did the does not equals alternative, that's when it would be two-tailed. Does that make sense, Bailey? So this shades to the right, this shades to the left, and the two tails shades both sides. So the way the alternative is pointed, like if it's pointing right, or if it's pointing left, like less than shades to the left, greater than shades to the right, like we're doing here, and two-tailed shade, or this right here shades both directions, like it shades this way and shades this way. So it's got the two lines and it goes both ways right there. So the does not equals would be both sides. Does that make sense, Bailey? Great questions. Like these are like the sign of the alternative tells you which way you shade. So the reason we're shading to the right of this line right here is because we're doing the two-tailed. But what if we said, you know, are the grades equal to this? we could do the does not equals alternative, and then the p-value, like if we had asked the question, like, are the grades equal to this or not equal? Then we would do this. We would shade like this. Like if the alternative all the way back up here at the start, we'd have to change the wording a little bit. And can I show your question, Ella? I'll show it on screen as long as you can just say yes or no, or like, he claims they. So there we go. He claims they are, then let's abbreviate. I just want it to be in there. They are different than 75. This is chapter 15 mostly, but a little bit about rejecting and failing to reject null. Then we're going to do some chapter 16 right after Ella's. But now, since I'm claiming they are different than 75, we have the does not equals. I've changed the question here at the start. He claims they are different. So this right here, my claim, means I'm going to do does not equals. Does everyone understand here that now the alternative, the way I've written it, is he claims they are different. That means we're using this alternative. And then when we get down here, we do the does not equals test. Does that make sense? Who's with me on this? Like, because we're using he claims they are different, here's the alternative, because that's relative to this. Then when we get down here, now we're shading both sides because we're doing the does not equals alternative, and this will double the p-value. So what was our p-value just a moment ago? It was 0. So let's change it. It was basically 0. Let's do the two-tailed, and if we go to the two-tailed, it's still basically 0. So with this p-value here, even doing this, what are we going to do to the null hypothesis? So everyone tell me real big right here, what are we going to do to the null? Since the p-value is lower than 0.05, we're going to what the null. Since the p-value is low, let's what the null. A low p-value doesn't necessarily mean there is a cause. Bingo, Kaylin. Great job, Kaylin. Yep. This does not mean there's a cause and effect relationship. It does mean that we do have evidence that Brian's students' grades, so it might not be Brian doing this. Maybe Brian got lucky and had a really great group of students, as always. It doesn't mean there's cause and effect, that Brian causes his students to get better grades than 75. It just means that we have evidence that his students do not make 75s. They make different grades, which they are higher. We could do that, the greater than alternative. And that's all the 4 steps of hypothesis testing right here covered again. Really good review. Let's take a look at Ella's question right here. I think you said you emailed me, Ella. Let me see. Let me go check out. Here it is, Ella's question. Okay. Yes. And let's see. Okay. Tell us what the notation here is here, everybody. You ready? I'm going to mark notation. Everyone help out. Oh, it is. I think you are correct, Ella. Wow, that's a weird one, isn't it? Claims to lose 10 pounds. Yeah, Ella, I think you got everything correct. I thought it was weird, but apparently I haven't seen enough versions of this question. I think this is one of the ones that can generate different answers. So there's no static answer to this one. Yeah, I think you are correct. It sounded weird. Yeah, it's just a very low value. So as always, practice our notation. We don't need degrees of freedom, but I mean, why not? We're here. Lose 10 pounds, mu naught, standard deviation of the sample, mean of the sample, and then oops, well, sure, why not? Does that make sense, Ella? Mu naught. Yep. And then you are correct. I was, yeah. That's it. Ella, you're doing great. That's awesome. Yep. Does this question seem a good bit easier now, finding the test statistic? Just the better you can identify the notation, the quicker it goes. And the n-1 degrees of freedom, I mean, it is important, but it's not going to come into play in this question because we're not going to find the p-value. So, I mean, we could go in and find the p-value, but the question doesn't ask us to. So we just did a full kind of step-by-step. But are people feeling better about this one right here? Does this make a lot more sense? How are we doing? Let's take a look. Awesome, Caitlin. Sorry, I got a Caitlin and a Caitlin here. Awesome, Caitlin. Will Simon 11 be posted? I think I could try to get it out later tonight. Does that sound good, Kayla, right there? Awesome. Let's take a look at the question that Marley had right here. I think I can get it out later tonight. I think I got I got everything done for the asynchronous class. I'm very happy about that. Got that done this weekend, so I'm very happy about that. Like I was like, yes, it's all done. I sent out the email this morning, and I forgot to put a due date on one assignment. So, haha, like I forgot last week, and so as rightly so, someone emailed me and they said, "When is this due?" And I said, "Wait, it's already due. I mean, it's not due now, but I didn't put a due date. Wait, oops. I am not perfect. I make mistakes. Is it the homework or the quiz? Let me look at the question again. Can you go over in a recent poll of randomly selected adults, presidential proven rating stood at? Okay, I think it's in the quiz. When is chapter 16 due? Due coming up. Okay, here we go. In a recently, wait, where'd it go? Did I close it? What did I do? I am losing my mind. I think I closed it. In a recent poll. It might be in the homework. Oh, here we go. We got this. Okay, let's take a look. Which one was it, Kayla? I didn't see Kayla's. Oh, yeah. I think it'll be out tomorrow at the latest. Nervous laugh. So, I think, did Julia get her? No, the t-value. The t-value will be the test statistic. Great job, Kaylin, right there. Kaylin, 50 points. Thank you for helping out while I was getting this loaded up. Thank you, everyone tagging each other, helping each other out. That's what we're here to do. So I really appreciate it. And I need to, might hook up the new wires. We got the new wires in, we let them decontaminate. Okay, so we need to make a 90% confidence interval. Let's start by identifying the notation for this question. Let's identify the notation. We always identify notation to begin with. So what do we see notation-wise right here? Help me with the notation. And I can see where people might get stuck on this. So we need the notation. Good to see you here, Caroline. Love the Mew Bucks. It's been a crazy morning, just giving out so many Mew Bucks. I'll pull up something we're going to need here in a second. Got that on the screen. And so what do we have notation-wise right here? What do we have notation here? I'll start highlighting stuff. And that's going to be a special thing right here. I'll write the equation. There we go. One of the best ways to memorize the equations is to understand the components of it. We just basically have a center plus or minus a margin of error. The margin of error consists of a z statistic, which can be picked based on the degrees of freedom. Hint, 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 hint. And then we have the standard error. Great job. Yep. Sample size is this. And what else? We're two few things short right here. So we're just a few things short. And great job, everybody. Equation sheet. Charlie knows what he's talking about right there. Charlie's like, equation sheet. Huge help for the final. Because if you know which equation to go to, you're like, oh, this is a confidence interval for the sample or the true proportion from the sample portion. Caroline, everyone like, yes, Charlie, you are right. Good to see you here, Charlie. Charlie, Pro 201 student. Yes, Marley knows what's going on. How many points does Charlie have? Gold tier, love it. Did I give you? You've got so many. Charlie, I should change your points around. So I remove the points after each semester. You keep your hours. So that way, if you take another class with me, you advance. I'll give you some points. So 0.52 will be P because it came from a what? So it'll be P hat because it came from a what? So P is the truth, like for the population, but it'll be P hat because it came from a sample. Correct. And so this is a Z interval, and it's because it's what kind of data right here? This is what kind of data right here. So it's a Z interval. Because we're asking, do you approve of the president? Do you approve of the president is a what question. See, it all relates to this. Even 320 talks about these kind of variables all the time. Because we're doing it with logistic regression in 320 right now. The y variable of interest is proportion. Is exactly, do you approve of the president? It's proportion. It's categorical. So couldn't get into BSRFall. I'm keeping a lookout. Yeah. No, and even if you don't get into my section, so Charlie, even if you're not in my section, I will hold office hours like this. You can attend office hours anytime. You can ask questions. You can say, and I'm going to try to link back up all the 320s next semester and all the 474s. This semester we were a little delinked, and it was a lot harder. So next semester, I'm going to go to all the teachers and be like, let's merge all our sections together again. Because truthfully, I have a better experience with that. Let's merge everything together and all be completely synced up. Let's all be merged together into one happy group. So just to make sure I understand, P comes first in the alphabet and P comes from yes, exactly. Why did I read first in the alphabet? I think I was thinking about 320 for a moment. P is for the population, P hat is for the sample. That's exactly right, Morgan. So the goal of this interval is to estimate P from P hat. The goal of this interval is to estimate P from P hat. And so we basically have it right now. We just need this. That's going to tell us the z-score. The z-score is 1.645. How do we know that? Memorization. Also, we have David M. Lane. Let's bring it back up right here. David. There we go. And there we go. Let's bring David M. Lane over here. And we want to make, go here, go to 90%. And then you have to graph the middle and, whoops, between. There we go. 1.645 is the z-score. And so that is the z-score we are obtaining right there. So we have the z-score, David. And so so we got the p hat is 0.52 plus or minus 1 hour till class 1.645 square root 0.52 times 0.48 over 800. Let's just solve this right here. And and we go 0.52 times 0.48 divided by 800 square root times 1.645, about 2.9%. I wish that could be 3%, but it's 2.9. So 0.52 plus or minus 0.029. There we go right there. I think that's all the decimals we'll need. And now we go back here. We go to this question. So there's that. So what does it want? Yeah, 0.549. And then we take 0.52 minus the margin of error. And we go here to 0.491. And they are claiming really? Test the null hypothesis of 52%. So 52 is at the center of the interval. What do you think we will do with 52? It's at the very center of this interval. What do you think you'll do with 52 because it's at the very center of this interval? 52 is in the direct center. Type 2 error occurs. Yep. Exactly. Because false and fail to reject it. Boom, right there, Jonathan. Yep. So type 2 is when it's false and we fail to reject it. There's the 2 F's right there. Great job, Jonathan. That's 100% correct. And so what do you think we'll do with this claim of 52 since it's in the interval? What do you think? What will we do with the claim of 52 since it's in the interval? The claim of 52 will be whatted. So 52 is at the direct center of this interval. So the claim of 52 can be whatted. P is the true proportion. Does it make sense, Miranda? I can do an example. I'll do an example question of that next if you want. So we will what the claim of 52? Because 52 is in the... Sure, yeah, here, I'll do that next year, Jonathan. We'll do a review of that. I'll do it in the... So we will fail to reject this because it's in the center of the interval. Everything's right? Got it. So let's go over here. let's talk about the signs right there and what they all mean. Let's go to the boss battle scene. Say hey to Mewbot. Let's go to boss battle scene. I gotta find out where my scenes are at. I hide these things away. Oh my gosh, look, it's crazy, Brian. Okay. Mewbot, go away. Okay. Let's go to the main screen. Okay, here we are. So this is what these mean right here, Jonathan. You ready? Brian's holding up a what right now? Just only look at this hand, really. The one in front of my face. Look at it. Brian's holding up a what? That's going to be confusing if I do that. Brian's holding up a what?
I am Mewbot.
I don't think his mad voice is there anymore.
I am Mewbot.
Oh, he's got his happy voice. 1. In a type 1 error, the null is what? In a type 1 error, the null is what? In a type 1 error, the null is what? In a type 1 error, the null is what? And look at what this makes right here. In a type 1 error, the null is what? And what does that stand for? Jonathan, you are correct. True. And so if the null is true, what would be an error? Think the null is true. It'd be an error to do what? What would it be an error to do?
I am Mewbot.
Mewbot, chill out. In a type 1 error, the null is true, and it'd be an error to do what? In a type 1 error, the null is true, and it'd be an error, because type 1 error, the null is true, and it'd be an error to do what? Reject it. That would be an error. So, of course, yeah, he's great. We'll be working together, so if you're taking with him, definitely, yep. Emery Demirakaya. Yep, Emery Demirakaya, yep. And so in a type 2 error, the null is what? Oh, good, I'm facing the right way this time. In a type 2 error, the null is what? In a type 2 error, the null is what? Awesome. Yep, and I'll be helping out. So, like, yep, type 2 error, the null is false, and we what it? And then what's the second? Like, in a type 2 error, the null is false, and it's an error because we what it? So in a type 2 error, the null is false, and it's an error because we what it? Exactly. And Cindy, you are correct. We fail to reject it. Does that make sense? So this is your 2Fs. In a type 2 error, the null is false, and we fail to reject it. In a type 1, the null is true, and we reject it. In type 2, the null is false, and we fail to reject it. Is it making more sense, Jonathan, just like practicing this? Just be like, in a type 1, the null is true, and we reject it. In a type 2, the null is false, and we fail to reject it. And you can just make the T and the F right there. And remember, it's 2Fs for the type 2. In the type 2, the null is false, and we fail to reject it. Yeah, Marley, you got that. We'll do that next. Great questions, Marley. Thank you so much. We'll do that one next. Does this make sense right here? Like practicing it. 2Fs, false, and fail to reject, Bailey. Exactly. And that's the way to memorize it. Like, you just have to memorize it, basically. It's like, in a type 1, the null is true, and we reject it. In a type 2, the null is false, and we fail to reject it. So, exactly. There's 2Fs in the type 2. That's like the whole thing of it. Like, a student made this up, and we worked on it together. Like, they basically made it up, and I was like, yeah, and it's just like memorization. So it's the whole thing, and we only talk about the null. Don't talk about the alternative. Don't talk about like we don't make statements on the alternative. We always say we reject the null. We fail to reject the null. So this helps with the wording of in a type 1, the null is true, and we reject it. That's an error, type 1 error. In a type 2, the null is false, and we fail to reject it. That's an error because we should have rejected it. I know I'm saying reject right there, but if the null is false, we should reject it, but the error is failing to reject it. Does that make sense? Because the null is false? Hopefully I'm repeating a lot of the same things. It's practice. You got to hear these things twice. You got to practice it. You got to hear them twice. I promise you, please come to class. Oh no, we're trying to, in one class, we're working towards man bun, Brian. In one class, we're working to, I'll have Chelsea put my hair up in a man bun. Maybe I'll sleep with it in a man bun. I'll wake up and we'll have man bun, Brian. But one class, we're trying to get 200 students to attend class live. Attend class, practice. That way, when you hear it in your review, you're like, type 1, the null is true, and we reject it. Type 2, the null is false, and we fail to reject it. It's practice. Practice, practice, practice. Practice. Practice makes progress. Kayla said that earlier. Let's take a look right here. We got another question. It's something about the intervals. Can you please go to the problem? Which of the following are true? Oh, here we go. Let's do it. For the lots of, would it be? You're still predicting alcohol right there. You're still, HTT, check, email me or message me on Discord and stuff, HTT. You're still predicting alcohol. Yeah, we can do that one next, Madison. Man bun Brian. That's what one class is working towards. I told him 200 people attending live. I think it's tomorrow's class. I told them 200 people attending live. So we need 200 people. Let's make it happen. Let's have 200 people attend live. I'm thinking about doing all the review as the Joker. Would you guys like it if on review day I appeared as the Joker? I might do like a 4-hour stream as the Joker. It'd be fun for me. I was just thinking about like it'd be fun. That's my class. Yeah, it's your class right there. Morgan's over talking about. It's you just go with it. This is like a watch what. I'll be there, and yes, awesome. Let's maybe we'll do review day as the Joker, like a 4-hour live stream Joker reviews statistics. I'd do like 320 and 2 run review. Okay. Which of the following statements are true? Serious face. Using an alpha of 0.05, a p-value of 0.04 results in rejecting the null. When do we reject the null? P-value what to alpha? So it says using an alpha of 0.05, a p-value of 0.04 results in rejecting the null. When do we reject the null? Everyone's got so much positivity. When do we reject the null? So using an alpha of 0.05, here's the alpha. A p-value of this results in rejecting the null. When do we reject the null? So here's the alpha. Yep, and technically, Marley, you're 100% right. It's when p-value is less than alpha, and alpha is usually considered to be 0.05. Does that make sense? You're 100% right, Marley. We've been going crazy with points. Yep, when p-value is less than alpha, and alpha is usually considered to be 0.05. So, yeah, and so this is all just practice. Great job right there. And everyone's saying p-value less than 0.05 because 0.05 is the assumed alpha. Alpha's literally just a limbo bar, and they're going to start messing with alpha right here in a moment. They're going to change it to another thing. Usually it's 0.05 unless otherwise stated. So everything is 100% right there. So using an alpha of 0.05, a p-value of this results in rejecting the null. That's 100% true. The alpha level depends on the sample size. What do I always say? True or false? You can just pick your alpha, anything you want. True or false? You can pick your alpha. It can be anything you want. True or false? Very, very what? It might even be a test question. You can just pick your alpha. You can just say alpha this. True or false? So you can put TRF in the chat. You can just pick an alpha level. You can just be like, alpha this. Here's my alpha. Very true. Alpha does not depend on sample size. Alpha, sample size, and effect size are the 3 things that impact power. That's a review that we could do. But the 3 things that impact power, which is the ability to correctly reject the false null, bunch of terms we should know. This is 100% false. Alpha is set independently, so it's 100%. You can just, as Leslie says right there, it's true. You can just pick any alpha you want. You could just say alpha 0.01. Does that make sense? You can just say your alpha is 0.01. So with an alpha of 0.01, a p-value of 0.01 results in rejecting the null. What do you immediately see right here? The p-value is what to alpha? What do you see right here? This p-value right here is what to alpha? This p-value here is what to alpha? Here's the alpha, here's the p-value, and they're saying we would reject the null. But this p-value is what to alpha? Which doesn't go with our trend with what we should do. This p-value right here is what to the alpha level? So 0.10 is what to alpha? It's greater than alpha. So we would fail to reject. So the statement is false because... No. Only a p-value less than alpha results in rejecting the null. We don't reject the alternative. We only make statements about the null. No, great job right there. Yeah, you're seeing it. You're like, oh, that's greater than alpha. So we would fail to reject the null, which they're saying it right here. The statement is false because only a p-value less than alpha results in rejecting the null. These are things we should know. Like, if there are things you should know right here, oh no, totally fine, Cooper, don't worry, you got this. It's just practice. So using an alpha of 0.05, 0.08 means the null hypothesis is true. Does Brian ever talk like that? Do we ever say we figure out the null is true? I never talk about the null being true. We only reject the null or fail to reject the null, so I got to disappear. So the statement is false because the p-value is greater than alpha only indicates, because this sounds a lot like what? It says there's not enough evidence to reject the null. This sounds a lot like we're saying we what the null. We say we don't have enough evidence to reject the null. This sounds more in line with saying we what? Because the p-value here is higher than alpha. There's not enough evidence to reject the null, so I what? Because it's literally saying I do not reject the null, like not rejecting the null. We do not have enough evidence to reject the null. This sounds a lot, because I sometimes say I reject or do not reject. We don't say the null is true. We don't say the null is true. So by saying there's not enough evidence to reject the null, we were saying you don't go to the mall, you fail to go to the mall. So this is trying to say what right here? By saying there is not enough evidence to reject the null, we're saying we what to reject the null. So we're saying we what, which is the classical way of saying it. Fail to reject. Exactly. We should get everything right. Boom, we got it right there. Wasn't too scared. Wasn't there another one people wanted to do from all this? Here, we'll hop back to space. Great job, everybody. Just some practice. Remember, when p-value is less than alpha, reject the null, and p-value is high, just let it fly, and means fail to reject. I think there was another one, right? Keep asking those questions. I haven't listened to any music today. It's like we need new songs. People are like, Brian. Oh, we got right here. Masson asks, can you explain the question on the Canvas content quiz that says if we construct a 95% conf role that does not contain the values to which the statement is true? Let's talk about that. Again. I need a third cup of coffee. Maybe some awake chocolate. Caffeine. Caffeine. I live on caffeine. So, if we have a confidence interval and we have hypothesized values, so let's do a hypothesized mean. So here we are with some hypothesized values. Take a look at these right here. Sure, why not? Take a look at these right here, and what do you think? If we have a hypothesized value that is in the confidence interval, what would you do with it? If your hypothesized value is in your confidence interval, like I tell you, the price of the new Nintendo system is going to cost somewhere between $500 to $700. And this is mean, like the average price, let's say in store, the average retail price we estimate to be between $500 and $700 for stores. I don't know why they would vary, because MSRP usually doesn't vary on Nintendo's, but let's just say. I estimate the average price is between $500 and $700. Now, what would you say to 650? What would you say to the hypothesized value of 650? Look at it right here. Here's my interval saying I think it's between $500 to $700. Kind of more of a theoretical interval. What would you say to the value of 650? The value of 650, you would say what to that value? You'd look at that value and say, I what it. Just don't even maybe think statistically. I failed to reject. Exactly. Caitlin, great job. That's the statistical way. You'd say like, I think it's possible. Does that make sense to say 650 seems like a possible value that could be true? Now, you're not saying it is true. That's why we don't say something is true. We just say we can't reject it. We don't have evidence to go against this. But this value up here, you would what it. This value of 800 is outside your interval, and thus we can reject it and say that we have evidence that 800, exactly, values within the interval we cannot reject. Values outside the interval we can reject at a 0.05 alpha level for the two-tailed test. And let's kind of write some notes on that right here. So, values, we're just listening to some chill music right here. So, values inside the interval, we cannot reject. Values outside the interval, all confidence intervals are relative to a two-tailed test with 1 minus confidence level equals alpha. What does this all mean? Let's review this. So whenever we do a confidence interval, like if I were to tell you that this right here was a 95% confidence interval. So if this was a 95% confidence interval, I want you to think about 95% inside. Oh, I should have done this also. Let me do this first. 95% inside. What does that mean is total outside? So if it's 95% inside. Oh, man. There we go. If there's 95% inside, what does that mean is outside this interval? So 95% inside. That means outside, which is like our rejection region. Does that does this make sense right here? You're fine, Lauren. Is this making sense how to do this right here? That since we have a 95% confidence interval, there'll be 5% outside. And so that's why we say if something's contained within a 95% confidence interval, like this value right here, it cannot be rejected at the 0.05 alpha level. So like these are like the bands of where it's similar as to that. It wouldn't do the exact same drawing. Exactly. And so when you look at this right here, this is inside of this. Like here we can draw the relative stuff to this. Like this right here would be here, first dot, and then second would be over here. So this right here would be here, and this right here would be here. So when you take a look, now it's going to do purple. Watch this. No, it didn't. Good. And so just looking at where our X's are, hopefully it's making sense here that these things that are inside the confidence interval we cannot reject, where anything outside the confidence interval we can reject. So the value of 800 is outside the confidence interval, and thus here's the confidence interval, and 800 was outside of it, and we would be able to reject it. Where 650 was inside the confidence interval, there's 650 there inside of it, and we would not be able to reject it. It would not fall into a rejection region. A new diet is being tested. Yeah, we did that one earlier, Parker. We can do it again if people want. We got time for like 1 or 2 more questions. We did it at the start. What do people say? We will do that one again. The key to that one's going to be notation. Notation, 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 notation. But hopefully this clarifies everything about confidence intervals and how if something's inside the confidence interval, we cannot reject it at the 0.05 or if it's a 95%. You could change this question right here and just make sure you understand that it's not always going to be 95%. It might not look perfect. My drawing might not be perfect. But there we go. For interactions, we only look at the strength and if it's positive or negative. Kind of an HCT out. We look at how it changes. So we want to talk about relative to the line being like this, hint, 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 and then it goes like this. So we want to talk about how it's different. How we should do that later today. How about we do that? How about we do that right after class, Reagan? Should we do that right after class? I'll send out an announcement and say let's have the quiz right after class, and then I'll try to make sure we have as many. Would people like that? I meant to do it this weekend and just got busy and life is busy. Yeah, Caitlin, let's do it right after class. So I'll send it an announcement. Let me go make that right now. I think, can I make streams? Let's figure out if we crash the stream right now. Will we crash the stream by doing this? Here, let's head to space while we talk about this. Okay, Brian's going to try to set up a stream for later. Send out the announcement. Tell people we're going to be doing it. YouTube Studio. Create. Go live. Today's class goes till 4:45. So we need to put it at 6 p.m. your time. 6 p.m. your time. It will be 6 p.m. Do we have 23 live viewers right now? Thank you, everyone who's just chilling out. Yeah, looks like we might have. So reuse settings, and we can do name the question you want to do. Okay, let's do this. So weekly review game, Canvas content help. Okay, and then I'm gonna try to hopefully. So this will be 6 p.m. your time. 6 p.m. your time. Oh, wait, we don't want this to be in gaming. We want this to be in education. Sorry, entertainment. I thought there's education. Education, there we go. It should be, okay, create. Make sure it's got the low latency on. Hopefully this doesn't cause any issues. Analytics, stream health, stream settings. Ultra low latency, we are good to go. It is created. Awesome. There we go. 3 hours? Holy mackerel. It's like more like 3.5 hours. So the link I'm gonna put in the chat real quick. There we go. Gives me time. Turn the mill. Awesome. Yeah, no, don't worry. It's more about how you think through it. You're welcome, Reagan. Thank you for reminding me. I'm glad they're so helpful. That's what I like. I love when the hoots are at a time I can come. Basically, they are usually on Fridays, and I work on Fridays. Oh, Caitlin, I'm so excited that you can play. Yeah, no, that's my goal. Is I wanted to move them around a little bit. It's just hard for some people I know who like I have to work at this time, Brian. It's like, and I work every Friday. So, Caitlin, good that we'll have you here tonight. I'll send out some reminders. Which questions do people want to do right now? So, what questions do people want to do? I've got my Easter candy. Oh man, Junior Mints eggs, so good. Is it? I would think the letters should go away. These are green. How's the green screen not doing those letters? Oh, I think it is being green screened. It is. It was just, yeah. I was like, those are green. You're welcome, Madison. Anytime. What other questions? We can do one. Some people were asking about ones we already done, which we can do those. We don't have any large questions right now. So I think Parker had one. They are pretty good. Yeah, they're like normal junior mints, but junior mints are good. So I mean, just like Easter egg junior mints. So and I was like, why did that not look? It was because it was green screening it. I was like, it should be green screening it because there's green. Any advice on visualization number 8? Yeah. So for visualization number 8, you're comparing two means. We could look at that real quick. We haven't put that in the video yet. So oh, awesome. Morgan, can you come to them tonight? Can you come to? Hopefully, people can tonight. I need to open a new data set. Where's the data? I'm trying to find the data. Okay. Oh my gosh, what is going on? Okay. Let's go take a look at visualization 8. Little advice for visualization number 8. Let's go take a look. So for visualization number 8, we're comparing the when's the final? Is it if people want to put in the chat real quick here? I put a video out on this. It's like don't quote. I'll look it up here after this in a second, Leslie. I'm pretty sure I know when it is. It's like May 4th at like 1 p.m. or something. There we go. Wait, look, Reagan put it right in the chat. I'm always afraid because if I say it off of memory and I'm wrong, good to see you here, Paige. If I say it from memory and I'm wrong, here, let's go just here. Well, let's disambiguify that. Let me go show that. If I say the wrong date, that's, like a bunch of people could watch the video. One time I sent all my students to the wrong classroom for our exam. I sent them to a broom closet, no joke. And so people were like, they started like, it was pretty crazy. So here we go. Let's see. We do offer sometimes here. I'll zoom out so you can. I'll disappear. Here's the time right here. We usually offer a little bit bigger of a window. Emma, that is correct right there. It looks like we usually have it open just a little bit earlier and have it go just a little bit later. It's departmental, so it shouldn't collide with any of the other exams. And we make sure there's enough. Everyone is like, "Hey, what's up? Good to have you here, everybody." So here is the date for the final. If you have a conflict, you most likely, only in rare circumstances, is stat to 1 the one that is moved. It's usually your other exams. What is Morgan? I have no idea, Morgan. But this is the time for the final right here, and it's usually the other exams that are moved because stat 1 is departmental. So like my exam, I have an exam that overlaps with other ones. I think it's one of these IMT classes right here overlaps with a 320 class. So I'm actually the one moving it because we're the non-departmental exams down here. So please make sure to reach out to your instructors. Technically, it should be last week to reach out to them, but because it should be 2 weeks before the end of class. But they should still work with you. They should be good like that. Yeah. When I did that, oh yeah, I literally sent them to the closet, and like it was, I sent out like an email like, hey everybody, if you're walking down here right now, make sure you're going to this room and not the other room because oops, I sent the wrong room number to everybody. Like people were standing in the hall and they were like, because I went, like I got there like 15-20 minutes early to the room because usually I get there early to set up when we teach from a room or when we give an exam in a room, and I show up and people are like, what room is our exam? And I was like, right here. And they're like, well, it says 224 and this is 223 Hebrew. And so and I was like, wait, yeah, we're in 223. That's what the room says. And they're like, no, your announcement says 224. And I was like, So since then, I've been really afraid to say something, especially if I'm wrong, because what if I were to say, "Oh, it's on such and such date," and then everyone's like, "Brian, you said in this video," and I'll be like, "Oh no." So I always like to, even though I kind of knew it as I was saying to someone put in the chat. Let's talk about a visualization number 8. So what we're doing right here, let me slow it down. Let's put this. Okay. Talk about visualization number 8 here for just a moment. So with visualization number 8, we're comparing two means. This is chapter 17. Let's go ahead and look at chapter 17. So this is comparing two means. How do we compare two means? Two means is interesting because both variables are not quantitative. Let me ask a question. Everyone pause for a moment. If we have two quantitative variables, what are we doing? QQ, straight enough, no outliers. Roderick, Kayla, anybody, what are we doing if we have two quantitative variables? Because we're not going to have two quantitative variables here. What would we be doing if we had two quantitative variables? This is a good review for tools and techniques for the finals. If we had two quantitative variables, what would we be doing? That's not what we're doing right here. If we had two quantitative variables, we would be making a this maybe, and we'd be doing what? If we had two quantitative variables. If we had two quantitative variables, we could make a QQ plot can be made for one variable because it's going to look at the quantiles versus the normal. So QQ plots are, interesting enough, and a histogram would be for one quantitative variable also. So if you look up there in the top left corner, but what would we be doing if we had two quantitative variables, like a quantitative y and a quantitative x? A scatter plot, which means we'd be doing regression. But we want to do this right here. We want to do a quantitative y and a categorical x. And think about this. We have side-by-side box plots then. Because just think about theoretically for a moment. If we're comparing two means, maybe we should have people in Greek life versus people not in Greek life. Do you see how we have two groups right here? Great job, Morgan, everyone. We have scatter plots with two quantitatives. If we have people in Greek life and people not in Greek life, and now we want to look at some quantitative variable, like, great job, Caroline, right there. We want to look at their GPA. Does this make sense? Let's look at the mean GPA for people in Greek life versus the mean GPA for people not in Greek life. Who understands that theoretically speaking? Like, theoretically speaking, we're going to look at the mean for this group and the mean for this group. We have two groups right here. We're going to compare the two means of the group, which is chapter 17, which we're going to be doing today. This is today's lecture. Tomorrow's lecture, if you're in tomorrow's class. We're going to look at the two means. We're going to look at the mean for the no group and the mean for the yes group. Makes sense. Awesome. So we're comparing two means. And here we go. We're going to go ahead and go to t-test. This is the two sample t-test. So we'll go here to the red arrow. Let me make this big. We're going to go here to the red arrow. And thank you so much. Good to see you here, Reagan and Caroline, everybody. We'll go here to t-test. Okay. So let's look at the results. So especially if you're in the asynchronous class, I go through and label all of these right here, all of these results. Now, this might be the hard part, looking at these results right here. So, you know, it's probably going to be best if I copy paste this, and let's talk about what these results say. Now, here's the tricks. If you can read this output, you actually know most of the chapter. So, with this output right here, the null and alternative are really easy to write. All we have to do is put a mu here and a mu here. And you can't really see that. Let's make it easier to see. We'll do it in yellow for once, because I think you'll actually will be able to see it. Mu, and we'll go green. Mu, mu. Awesome. Because the null is that the mean for yes minus the mean for no is equal to 0. The alternative is that the mean for yes and the mean for no is not. We could do whatever. We could choose any of these down here. This is the not equals alternative right here, though. This is the not equals alternative. This is the greater than. This is the less than. So we could pick like is not equal to 0. Just depends on how we word the question. But those are the alternatives and the p-values associated with them. So when we look at this right here, here's a tougher question on the test. You ready? Which group had a higher mean GPA? Yes or no? So what do people think? Which group had a higher mean GPA? Yes or no? Which group had a higher mean GPA? And the difference right here is negative. So I want us to think about two possibilities. We have possibility 1, like 3 minus 4, or possibility 2, 4 minus 3. Since the difference is negative, then which group, you can say the first or the second, or the which group had a higher sample mean? It'd be the no group. Good, Caitlin, right there, 50 points. Don't worry. It'd be the no group. Because the second number is bigger, that means the difference being negative right here means the no group was higher. Does that make sense? So the no group was actually higher because if you do like 3 minus 4, you get a negative difference. So the sample mean for yes was smaller than the sample mean for no. Does that make sense right here? Like the no has to be the bigger number because the sample difference was negative. So no had a slightly higher mean because smaller number minus bigger number means negative difference. Does that make sense? Yeah. Once you see it, you're like, okay, if the difference is negative, and just think about how the negative is associated with this one. So if it's negative, that means, no, this is the practice. This is the practice. You're fine. When you see that on the test, you're like, oh, the second mean is bigger because the difference is negative. Now, the standard error of the difference is, so this right here is, yes, minus 1, no. Sorry, this is going to take a moment to write this one. Do a minus? No. There we go. Okay. You don't have to, we rarely have you solve this, but it should be the yes group, the s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So this right here is the standard error of the difference. The standard error of the difference is basically like the standardizing factor. And you know what's really interesting? If you divide these two numbers right here, what do you think you get if you divide these two numbers, which you should definitely know this for the test? If you divide these two numbers, what does that equal up to mathematically? If you divide those two numbers, what will that equal up to? If you take the difference and standardize it, you'll get the what? If you take the difference and standardize it, you'll get the what? If you take the difference and standardize it, you'll get the what? If you take the difference and standardize it, you'll get the what? So we just take the difference and we standardize it. And look at this. This is the t-value. It'll give us the t-value. So if we take the difference and standardize it, we get the t-value. And so that is literally these two numbers divided. Does that make sense? Logistic model on task 2. We'll try to do that next year. We'll try to throw that in, Master. You got it. Or X. And so next we see let's see, we'll unhighlight this. Is our lowest visualization dropped? Yep, that is true. 100%. Lowest visualization dropped. What do you notice here about this interval? Which is a very interesting thing for this 95% confidence interval. We estimate that the difference is that maybe the no group, the people not in Greek life, have a GPA that is maybe 0.05 higher, or it could be that the yes group has a GPA that is up to 0.02 higher. What do you notice is contained in this interval right here? What value do you notice is contained in the interval for estimating the difference? What value do you notice is in the interval? And which one were you wondering, X? If you can go into more detail, we'll do a little bit of that here in a moment. What value do you notice is contained in the interval? What value do you notice is contained in the interval for the difference we are estimating? What value do you notice? What hypothesized value? Because we're saying we think it could be that the no group, and this is visualization 8 right now. I'm not in your class, but I'm going through mathematics for machine learning. Is your class set one? Oh, that's a great question. Venjot. Tell me if I'm mispronouncing Venjot. I'm not in your class, but I'm going through mathematics for machine learning. Is your class set one? Class for. Maybe email me at bstevens@utk.edu if you explain into more detail, or just ask some more questions related to it. Probably not 201, probably more 320. Thank you for swinging by and glad to have you here. Probably not 201 for machine learning. You want to do more coding. 320 focuses more on coding, and so we were just doing some coding here a moment ago. And we do some machine learning in 474. So you're looking more at, you probably want to be learning either Python or R, or I don't know if people do a lot of machine learning in C++, but that's a really great question. 201 is going to be like a lot of the basics for what people do for like, let's say you're doing kinesiology or you're doing supply chain or you're doing marketing, understanding and how to utilize statistics. It's kind of a general knowledge statistics. And then when you get into like 320 and 474, 320 is regression, which is model building, which goes into kind of bridges into machine learning, because machine learning is going to be like, genetic algorithms and neural nets, some more higher level like tuning parameters, which if you know about tuning parameters and making sure data works on new or models work on new data, holdout samples versus validation. So really amazing question right there. Thank you for swinging by. Then maybe especially swing by another office hours. I might be able to talk more about machine learning. But I would say you're probably wanting to look at, oh, thank you so much. Thank you, Morgan. All the positivity. Let's throw some points out here for our visitor and everybody. Yeah, you're probably looking more towards like 320, 474, the higher level classes that are going to do more programming and focusing in on like what is the power of kind of programming. 201, which I think is an excellent course, focuses in on interpreting and understanding output and utilization across all different majors, because it's a very general course, which is great. You get the general knowledge that with this right here, we cannot reject this value of 0 because it's contained in the interval. And we also see that here for the p-value relative to the test. The degrees of freedom is going to be a complicated formula. Let's do X. We got just enough time for your question. I'll be teaching here in 21 minutes. I love it. We have so many awesome visitors, and I love it. I love it when someone swings by and they're like, "Hey, I have a question about this." It's like, "Oh, cool." Like maybe they're a UT student, maybe they're not. We're happy to have people come by and say, "Hey, oh, did we talk about the percentiles? I should mention that in class or not." Okay. So X was wondering about predicting the quality of wine from a quantitative variable. So let's look at this. Okay, so X, we are making a what type of model right here? We're going to predict the quality of wine from, let's say, sulfates, which I think sulfates is a capital. We are predicting the quality of wine from sulfates. So we're making what kind of model? What kind of model are we making? This is very important to this question. What kind of model are we making? What kind of model? I think I have it attached. I do. It is lowercase. So this is really important right here because we're going to go to family and it will autocomplete, but don't let it. And it's very important to know we're making what kind of model right here. Oh, no, yeah, that'll be super important. That'll be super important because we're making a logistic regression. And what does binomial mean? Think of bi, it means there's how many options. So when it comes to binomial, and nomial is like when we talk about a nominal or ordinal variable, nomial means it has like levels, which means it's a what variable, and it means there's how many levels. So when you break down binomial, we're talking about a blank level blank variable, 2-level categorical variable. So that's what binomial means. You can think of it as 0 and 1s, like binary is binomial. So we have here 0s and 1s, and when we plot this model here, what you'll notice is, as it keeps pushing the output over, what you'll notice is we get, ooh, that's an interesting model. We get that the probabilities on this are going to be relative to 0 and 1. We get a little bit more of the axis right there. And you can see as sulfates increases, or two wines that differ in sulfate by, like whatever the percent here is, or if we're looking at the amount, two wines at different sulfates, where one wine has more sulfates than another, the one that has more sulfates has a higher probability of being lower quality. And that's actually the interpretation of sulfates right here. We don't interpret the coefficient. And is this making more sense right here? I think the big change is you can't use your regular regression model. You have to go in here and use your y tilde x comma data equals comma family equals, and it has to be family equals binomial. So you have to do family equals binomial, and you have to do GLM. So when we're doing this, we're doing the generalized linear model. The generalized linear model is just, and you see it's by default Gaussian, which is actually the normal curve. Gauss made the normal curve. What else called Gaussian? I mean, he's Gauss. It wasn't Gaussian. All awesome. And so now it's working. Good to see you here, Lily. So hopefully this, I think they're nailing. I would think my neighbors wouldn't be crazy enough to be like, shut up. So hopefully we see here with the Gaussian that it is, everything's good. There we go. I think that's got it. I think they're nailing. They like nail something every week or something. So with this, we'll put on some music. We'll hope the neighbors aren't mad at me. What can I do if they're mad? I'm just gonna play this song 10 times. I think it's got everything. Head back here to space. Go get some food. Well, that's got it. The background is still broken-esque. With that, I'll be seeing everyone later. I will see everyone later. Happy to have fuel swinging by. Great work this morning. I know. It's a really quick story, Morgan. So when I was in the fort, like this year ago, I was teaching from my apartment, and I was teaching at like 7 a.m., 8 a.m., and all of a sudden, so I was teaching. Thank you, Paige. You're welcome anytime. So I was teaching, and then all of a sudden I hear like bang, 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 bang. And it wasn't like, it was kind of obvious they were mad. Like my neighbor was definitely like, shut up. And it's the fort. And what can I do? Pandemic, teaching from my apartment. And so, yeah, that was, and I was like, oh no. And from then on, I tried to be quieter. But we should be pretty good right here. We only have one neighbor. They shouldn't be able to hear me on the other side right there. But that was definitely like, I was like, I should find that video where my neighbor was like, it was so loud. Anyways, I've had that fear ever since, that maybe I get too loud and downstairs neighbor, next door neighbor can hear me. What can you do? We're living in a crazy world. I'll see everyone later. Bye for now. Bye, everybody. Gotta love the fort. Mubot, do you love the fort?
I am Mubot.
You're awesome, Mubot.